Hello friends, today we will be doing the magical technique to count the number of integral points inside a closed figure. To understand this concept, we'll take help of a question which we posted on our Instagram and Facebook pages on January 3, 2021. The question goes like this: if a point is selected at random from x square plus y square is less than or equal to 81, then what is the probability that it would lie on the circumference if x and y both are integers? Here the sign less than denotes that we have to count the points inside the closed figure, and equal to means that we have also to count the points on the boundary. So let us try to solve this question. The question talks about an expression which looks like this, and it means that whenever we have an expression like x square plus y square is equal to r square, that is the equation of a circle with origin as the center and r as the radius. In this question, the radius is 9 because r square is 81. Let us have a look at this circle. Now, the question looks very simple, and a lot of people might think that the solution is something like this, that they will first of all calculate the circumference, because circumference will be counting all the number of points on the boundary. And then they can divide it by the area, because area will be counting all the points which are inside the boundary and on the boundary. But here the problem is that if we count the circumference, we might be counting infinite points, and not all of them will be integers definitely. And similarly for area as well, if we count the total number of points, it will be all sorts of points inside the figure which can be irrational and fractional. But the question specifically asks about the integral points. Therefore, if we go like this, our answer would definitely be wrong. Now, to have a proper understanding of the question, we must try to make a diagram on coordinate axis. So here we do it. This is the x-axis. This is the y-axis. And this is the origin. The figure, that is sun, denotes the origin, which is 0, 0. Now we'll draw a circle. The circle has radius 9 units. Therefore, we can draw parallel lines to x-axis on both the positive and negative directions, and we can draw 9 lines each like this. So these lines are basically integers: 1, 2, 3, -1, -2, and so on. And similarly, we'll draw lines parallel to y-axis: -1, +1, -2, +2, and so on till -9, +9. Now, wherever these lines, the vertical and horizontal lines, intersect, they are the integral points which we have to actually count. And there's one way that we can actually draw the diagram and start counting the number of points, but of course that will be quite tedious and a long process. We have to do something which can be a shortcut technique. So before going to the technique, let us understand which points do we have to count. Here the yellow smileys represents the points which are on the circumference, and they are integers. As you can see in the figure, there is no point which is an intersection of the vertical and horizontal lines which is lying on the circumference, except these 4 points: the 9, 0, -9, 0, 0, 9, and 0, -9. Similarly, the pink smileys would denote the points lying inside the circle. There are so many points. I'm just giving you an example, I'm not counting all. So these are the points which are lying inside the circle. Similarly, there will be some points which will be lying outside the circle, which we do not have to count, and these are the points. Now, what if such a question is asked in an exam? Do not worry, here comes the magic technique. 1 + 4 sigma x is equal to 0 to r square bracket fx, where sigma denotes the sum of the series and square bracket denotes the integral part. Integral part means if we have something like 2.65, we'll only take 2. So that is what this means. Now we must learn how to use this magical technique to solve our question. The equation of the circle with center as the origin 0, 0 and radius as r is given by x square plus y square is equal to r square, which further implies that y can be represented in terms of x as square root of r square minus x square. In the question, the value of radius, that is r, is equal to 9. So y in terms of x can be a function of x. This will be equal to square root of 81 minus x square. Now if we apply the magical formula, which is 1 plus 4 sigma x is equal to 0 to 9, because radius is 9, and square bracket 81 minus x square. Now if we expand this, we'll get 1 plus 4. There is a huge bracket, and inside that bracket there is an expansion of the series where we will shuffle the value of x from 0 to 9. So the first bracket is the square root of 81 minus 0 square. Second bracket is the square root of 81 minus 1 square, and so on till square root of 81 minus 9 square. We should not forget that the square bracket is representing only the integral part. Now all we have to do is to evaluate the expressions inside the bracket. Let us do it. So here there is a table. In the first column we have the values of x from 0 to 9. In the second column the values of x square are there. The third column we have 81 minus x square, the difference. And then we have square root of whatever is there in the third column. And then we'll take the integral part in the fifth column. For example, looking at the first row, x is 0, x square is 0, 81 minus x square will be 81, and square root of 81 minus x square will be 9, and the integral part will be 9 only. Similarly, if x is 1, x square will be 1, 81 minus x square will be 80, the square root is 8.94. Of course, you don't have to use the calculator over here. You can just guess the square root, because 80 is greater than 64 and less than 81. The square root of 64 is 8, the square root of 81 is 9, so anything in between would be having a square root which will be 8 point something, like in the case of when x is 1, 2, 3 or 4. In all those cases we have square roots as 8.94, 8.77 and so on, so the integral part will be 8 only. Now if we count the total integral points, that is 9 plus 8 plus 8 plus 8 plus 8 plus 7 plus 6 plus 5 plus 4 plus 0, we get 63. And the points on the circumference are represented by red ink. That is when x is 0 and when x is 9. So we'll be having 0, 9, 9, 0, and similarly the negative part of it as well. That is 0, minus 9 and minus 9, 0. So overall we have 4 points on the circumference and 63 points in the entire circle including the circumference. So our answer becomes 4 upon 63. That is the probability.